Hey there folks, In the last video, I succinctly demonstrated how to destroy an enterprise server chassis so that it could be used for a wall-mounted computer setup. Toward the end of that process, I blasted what remained with a can of spray glitter that added a baller sauce color shift effect to what was an otherwise dull and boring gray metal. In this video, I'm going to unbox and prepare a number of the hardware components that will be used to build the final machine. There's nothing quite like the exhilaration that comes from slicing open the holographic stickers on new hardware packaging for the first time, and there's sure to be a few of those today. But for now, let's get down to business and set this pigeon free. First up, I'll talk about the motherboard. I'll be using the Gigabyte Z790 Oros Master for this build. This is an Intel LGA 1700 board that, for me, has two majorly positive characteristics. It has onboard 10 gigabit Ethernet, and it doesn't have Meg or Maximus in the name, which would in turn put extra digits in the price tag. It's a heavy board, so hopefully that translates to being well built. One thing I'm not a fan of is the bird with the dislocated jaw on the box. As long as it performs, I guess I will look beyond the mascot. Since I will be using a Delidded CPU, along with a direct die cooling solution for the CPU, I will need to perform some surgery on the CPU socket prior to installation. Next up is the CPU. I'll be using the Intel i7 14700K, which is a 20-core, 28-thread part. This component will be undergoing a deeply transformational experience via delidding. Having used Ryzen and Threadripper parts for the last few of my own personal builds, I wanted to get some additional hands-on experience with Intel's latest offerings, despite the recent release of AMD's Zen 5 CPUs and the widely reported problems with the Intel 13th and 14th generation processors. Supplemental to the delidding, I'll be using the Iceman LGA 1700 full nickel direct die Waterblock for cooling. There's been lots of activity for recent CPU generations when it comes to direct die cooling, with companies like EK, Iceman, and Supercool all having products that address this segment, but in terms of performance, minimalist design, small motherboard footprint, and low-ish cost, I prefer the Iceman block to the others. Low cost is especially fantastic for this entry-level, budget-friendly build. For the GPU, I'll be using the Gigabyte Gaming Overclocked RTX 4090 from NVIDIA. It seems the strategy for new graphics card technology is to ensure they leave the factory with as big of a fan and heatsink that Maersk Sea Transportation will allow for transit, and this model is no different. To cut down on the size of this beast, I'll be removing the stock cooler and replacing it with the EK Quantum Vector2 Master RTX Waterblock in Nickel Plexi. The memory I've selected is the G.Skill Trident Z5 32GB DDR5 dual-channel memory kit consisting of two 16GB sticks. The latency timings for this kit are 30, 40, 40, 96. For the primary hard drive, I'm using the 1TB SK Hynix P41 Platinum NVMe SSD. To provide enough power for the components, I'll be using the NZXT C1200 1200 watt gold power supply. To connect additional SSDs to the system, I'll be using the LSI 9305-16i SAS3 HBA. I won't be using any expanders in this build, so the SSDs will connect directly to the controller card via mini SAS 8643 breakout cables. This will provide 16 additional SATA ports, and in conjunction with the 4 SATA ports on the motherboard, will give me a total of 20 connected SSDs. Okie dokie, with the component readout complete, I think I'll tackle the CPU delid first. Let's get the box open and cut the factory seal. With the CPU free, let me talk briefly about the two delid tools I keep handy. On the left, I have the EK Quantum Vector2 IHS removal tool, and on the right, I have the RocketCool Delid tool for Intel 12th, 13th, and 14th Gen CPUs. I oscillate between both of these tools when it comes to delidding Intel processors. I've had both perform spectacularly, I've had both fail, so I don't really have a preference. In my opinion, the RocketCool is simpler in terms of usage, while the EK uses a more complex motion to work the IHS free from the CPU. Today, I'm going to use the RocketCool Delid tool, but it was a coin toss that determined that. There are other delid tools out there besides these two, But regardless of the tool you choose to use, always be aware of the position of the SMDs on the surface of the CPU. While both of these tools are keyed and marked to make them as safe as possible, just be aware that dropping the CPU in the tool in the wrong orientation will likely push these SMDs right off the surface of the CPU, resulting in what FPS Russia used to call a very bad day. Up first is the EK IHS removal tool. There is a main tool housing and a reversible sliding insert to push and pull the IHS off the CPU. There is a side 1, which pulls the IHS forward to a certain point, and once it reaches that point, you flip the CPU around to side 2, reorient the slider to accommodate side 2, then push the IHS back in the direction it came from. EK's own Delid instructions state to repeat this process a few times, and from experience I can say that's accurate. When looking at the CPU, this is how the two motions work together to eventually shear the IHS free. One thing to note about this motion is that it operates back and forth on the long side of the CPU. On to the rocket-cooled Delid tool. By comparison, this is a simpler tool and comes apart at the center into these two pieces. The triangle marking in this corner is meant to align with the corner of the CPU that also has the triangle mark. With the CPU oriented correctly, you bring the two parts together again, and thread the 3 screws into these positions, and then it's ready to crank. There is a singular motion to this tool. When the large cap head screw is turned, the pusher exerts force on the IHS until it shears free. This action occurs on the short edge of the CPU, and something I do like generically about this is that the action occurs in a singular direction away from the SMDs. As I said at the top of the program, both of these tools work, and I've used them to delid countless Intel CPUs. However, today I'm going to use the rocket-cooled Delid tool. I like to start my delid process by applying heat to the CPU with a heat gun. I use this Diafield model with adjustable temperature, though the temperature is controlled via this dial as opposed to a digital readout. This model goes all the way down to 112 degrees Fahrenheit or roughly 44 degrees Celsius. The delidding process doesn't take much heat, and I've configured this model to exactly the point on the dial that produces exactly how much heat I want on the CPU, which in this case, that's 75 degrees Celsius or 167 degrees Fahrenheit. Some folks bake their CPUs in a small oven, which can also work just fine. I'll lay the CPU out on a heat-resistant silicone mat, and with the heat gun outputting 75 degrees Celsius, go slowly back and forth over the surface of the CPU with the tip of the heat gun about 4 inches from the surface. I'm going to do this for 2 to 3 minutes to sufficiently heat the IHS. Once the CPU is warmed, I'll quickly transfer it to the Delid tool with the triangle on the CPU lined up to the triangle on the tool. Next, I'll insert the 3 flathead countersunk screws and tighten them down. With the screws in place, I'll take the larger hex key and start to turn. After a few full rotations of the wrench, what sounded like grandma's teeth cracking while biting a gobstopper was actually the sound of the IHS shearing free from the indium sheet and the gasket glue. With the primary separation complete, I'll unscrew the 3 screws on the Delid tool and remove the top piece. While applying a very small amount of topside pressure on the IHS, I'll use a small flat edge tool to slide the IHS from the die, and directionally doing it away from the SMDs. Once I can grab it with my fingers, I'll gently lift the IHS from the CPU, revealing the die underneath. Delidding complete. Now it's time to move on to the cleaning steps to remove the remaining indium sheet on the top of the die, and then remove the glue gasket from the perimeter of the CPU. With the CPU still in the Delid tool, I'll use regular old masking tape to surround the die and protect the rest of the surface area. Once the tape has been applied, I'll plop a small drop of Quicksilver solder remover on the center of the die. I'm using Quicksilver because I have it on hand. If I didn't have Quicksilver handy, I could use liquid metal for the cleaning step just as well. Using a lint-free electronic swab, I'll slowly start to spread the Quicksilver out across the full surface of the die. After it's been fully covered, I'll leave it sitting just like this for 10 to 15 minutes. Once that time has passed, I'll use more swabs to gently nudge and scrape the solder from the surface. At the point where rubbing the surface starts to feel smoother, I'll use paper towels, regular Q-tips, and 91% isopropyl alcohol to clean the surface as thoroughly as possible. If there's still solder after cleaning, I'll repeat these steps until no more indium remains. Sometimes it just takes 2 or 3 passes using this method. I'm not going to cover other solutions or chemicals that could be used to remove the indium, but enterprising individuals might choose to use something else that's a bit more effective for this step. At this point, the CPU looks like this. After a second pass, it looks like this. There are still 2 small islands of solder that should be removed before moving to the polishing step, but I'm going to leave them there to show you what it looks like if you don't remove them prior to polishing. My polishing paste of choice is the Flitz Metal Polish and Cleaner, which by the way is the same paste the Rocket Cool folks use as part of their delidding process as well. I'll dab a small bit on a strip of microfiber eyeglass cleaning cloth and slowly work in circles to clean the die surface. This step usually takes a few times to clean adequately as well. You can see as I start to smooth the surface of the die with the polish that the areas of indium I left turn a blackish color, very similar to coal. As I mentioned before, it should really be your goal to go into polishing with all the indium removed, but if you do find yourself with a thin section of it still on the die, it isn't the end of the world. Here's how it looks after 2 passes of polishing. What was a hazy and cloudy appearance is now a mirror finish. This Magic 8-Ball says, Dreamcast games. Now I'll use some alcohol on a paper towel to clean the entire surface of the tape as well as the CPU die, and then remove the tape holding the CPU in place. Next up is removing the gasket from the perimeter of the CPU. I use a combination of a plastic straight edge tool and orange wood nail sticks to scrape the material free. I'll also add a small swatch of tape in one corner of the CPU just to give some additional hold on the component so it doesn't fly out while cleaning it. In the corners with the SMDs, I'll orient the CPU like so and scrape in this direction. And I will never scrape in this direction. This is a time-consuming but not difficult step in the process of preparing the CPU for direct die cooling. The way I go about doing this is to hold the CPU at an angle so that ambient light in the room reflects onto the surface of the CPU such that I can very easily see where there is material remaining that needs to be removed. As needed, I'll use one of my kids' watercolor paintbrushes to gently broom the glue bits off the surface. Once all the glue has been removed, it's time to hit everything with alcohol and Q-tips. If I find an area that I missed, I'll clean it up now. It's very important with direct die cooling to remove as much of this material as possible. And here's what we look like after cleaning. With the CPU ready, I'll set it to the side and talk briefly about the Waterblock. Direct die cooling on Intel's more recent platforms has a bit of a storied history. From the semi-prevalent defects with EK's blocks, to the different styles of mounting mechanisms, and the fact that many of the blocks are most readily available on sites like AliExpress, just getting a good block to install can feel like a hassle sometimes. My personal opinion is that the Iceman block is just about the best solution for the money these days, but your needs might be a little different than mine. The underside of the block has pre-cut indentions for the areas around the cold plate where there are SMDs. The in and out ports use minimal iconography to indicate flow direction, and it's a simple block to be sure, but that generally aligns with my sensibilities. One thing to watch out for is that some motherboards have small capacitors and transistors around the perimeter of the CPU socket, and it's important to be sure that the Iceman block won't press on the top of any of that motherboard circuitry. On my motherboard, there aren't any areas to be worried about since things are relatively spread out. But on some boards, especially in super small ITX boards where this area can be kind of cramped due to the smaller footprint, there might be some areas for concern. If you were to discover that the block would sit on top of these components, you need to use a Dremel to shave, or a sharp razor to cut, enough material off the bottom of the Iceman block to ensure that those components are not crushed under the contact pressure of the block being attached. This is a fairly well-known foible of this water block, but as a DIYer of any standing, it shouldn't scare you to possibly need to shave down the block to make it fit. It's not a difficult task and ultimately not that big of a deal. I'll now sit the motherboard up on the workstand to remove the OEM CPU mounting hardware. First, I'll spin the motherboard around so I have access to the back, and put a piece or two of masking tape lightly over the OEM backplate. Then I'll spin the motherboard back around to the front, release the tension arm on the CPU socket, and open the cover. Being very careful not to stab the CPU pins, I'll use a T20 Torx bit to remove the 4 screws around the socket and gently lift the OEM mounting hardware from the surface. If you've got shaky hands around the pins, you could place the CPU in the socket and leave it there while removing the screws for an added layer of protection. Once the 2 latches have been removed, I'll pick the motherboard up and lay it flat on the table. Next, I'll place the delidded and very clean CPU in the socket. I'll be using Thermal Grizzly Conductonaut liquid metal on the die to maximize the cooling potential for this setup. Push a very small drop of liquid metal out of the syringe in the center of the die, and, using a lint-free swab, I'll start to spread the liquid metal around the surface. Once complete, if any of the material is pushed over the edge of the die, I'll run a Q-tip down the edge to remove that material. It's actually very easy to use too much liquid metal, so try and keep the application as minimal as possible. Some folks use a conformal coating of some sort over the SMDs to prevent accidental bridging from spillage of the Conductonaut, but most of the time I don't bother applying it. For one, the primary SMDs are positioned to the top and to the left of the die surface, and if some of that liquid metal were to drip, gravity usually doesn't cause drippage horizontally or vertically up, so the threat vector of those positions is minimized in my opinion. Secondly, the best protection against shorts is to not use too much liquid metal to begin with. But like I mentioned before, it can be very difficult to gauge whether you've applied too much liquid metal, so in that case take the precautions you feel necessary to prevent system damage. Some folks will use a certain kind of nail polish without benzene derivatives as a coating, but Thermal Grizzly also makes a product called TG Shield for this purpose, and my personal preference is to use MG Chemicals 419D or 419E acrylic conformal coating products. On a number of occasions, I have utilized the fluorescent characteristics of the product under a black light to see where I've applied it on the surface of PCBs, so it's my go-to product when doing that kind of thing. With the CPU prepared, I'll turn my attention to pre-applying a thin layer of liquid metal to the cold plate on the CPU block. Since very little liquid metal is needed, I'll continue to use the swab from when I applied it to the CPU die, as opposed to putting another drop from the syringe. The area of the water block that needs to be covered from the upper left corner is in 4.5mm, down 9mm, and the spread area needs to be 11mm tall by 24mm wide. I'll use my digital calipers throughout the process to ensure I'm putting the material on correctly. While these measurements are not accurate down to the nanometer, they've been perfectly fine for my builds. Bear in mind that these measurements assume that the block has been placed upside down, with the triangle on the water block now resting in the upper right-hand corner. Once the liquid metal is applied to the water block, I'll carefully set it down on top of the CPU, with the triangle mark on the block aligned to the triangle mark on the CPU and on the motherboard. Once in place, I'll use the 4 OEM CPU socket screws to fasten the block to the motherboard by tightening them in a cross pattern until each is fully secured. That completes the install of the Iceman CPU Waterblock. On the back of the motherboard, I'll now remove the temporary masking tape I applied earlier. One thing I really like about the Iceman block is that it utilizes the OEM backplate for mounting. As long as a product exists that uses the natural backplate, it prevents me from having to drill access holes on the motherboard mounting tray to be able to dismount or remount the CPU block, without first necessitating that I take the motherboard completely off the frame. To that end, I am going to apply Kapton tape to the perimeter of the backplate to keep it in place during dismounts and remounts of the CPU water block. The tape I like to use is the Elegoo High Temperature Kapton tape, which is a polyimide tape with silicone adhesive, so it's perfectly safe to use on electronics. Additionally, it can withstand temps as low as -73 degrees Celsius and as high as 260 degrees Celsius. Since there's quite a bit of surface area to work with here, I'll use the 1-inch wide tape roll and apply a small bit of tape on each of the 4 edges of the backplate. With the Kapton tape applied, I'm ready to mount the motherboard to the frame a little later on. Next up, I'll tackle the GPU, the Gigabyte GeForce RTX 4090 Gaming Overclocked. An interesting characteristic about this model and other 4090 cards is that they require my camera to be in ultra-wide mode just to get the whole thing in the picture. And holy crap, is that a driver disc? Nah, just a registration card for a warranty I'll never be able to use. In the box, there's also a quad 8-pin to single 16-pin 12-volt high-power connector, which isn't going anywhere near this card once it begins receiving electricity. And there's also an anti-sag bracket. The card itself has the WindForce triple fan setup, which I'll be removing in short order. The dimensions of the GPU in its native configuration is 5 1/4 inches tall, 13 1/2 inches long, and 3 inches deep. To get this party started, I'll lay out a sheet of 1-inch foam that I typically use for creating custom rifle case inserts, but also works great as a work mat for GPU surgery. I'll flip the GPU over where we'll remove the first 13 screws at these locations. These screws hold the stock fan assembly to the GPU. With those screws removed, I'll flip the GPU back over with the fans facing up and start to work them free from the card. The trick to removing the fans easily is to apply downward force on the I/O bracket and upward force on the bottom of the fan at the same time. There are two positions, both on the I/O bracket, that I'll alternate between. This area at the bottom of the bracket and this area at the top of the bracket. Start by applying downward pressure on the I/O bracket and upward pressure on the bottom of the fan housing, and once you encounter resistance, hold the position for about 10 seconds. After 10 seconds, switch positions and apply the same bidirectional pressure. There's no reason you couldn't apply pressure in both of these positions at the same time, but when I've done that, it has resulted in a sudden thwopping sound where the fans dislodge from the GPU somewhat violently and all at once. Personally, I like the control of doing one edge at a time so that it pops up consistently and slowly, depending on how aggressive I am with the pressure. Continue this alternating pattern until the rear posts pry free from the thermal pads. Once the separation starts to occur, apply some pressure at these locations by pressing a finger down on the PCB to provide some downward force closer to the die area. Do not apply this pressure to the PCIe connector, but higher up on the PCB. Continue alternating between the positions on the I/O bracket and soon the whole assembly will pry free and fold apart from the main board. With the fan housing sitting in this position, you can see 3 connectors that need to be removed at these locations. The small 3-pin connector I'll remove with a standard pair of needle nose pliers by gently squeezing on the plastic plug and rocking it back and forth. For the other 2 connectors, I'll use a pair of vice grips, which I've preset the jaw opening to 13.65 millimeters. I'll use my digital calipers to set the opening to exactly that. Both of the remaining 2 connectors are the same width, 13.95 millimeters, so I can pull both of these off at the same time without reconfiguring the vice grips. With these 3 connectors removed, the entire fan assembly will be set free, and we're left with this. The next step is to remove an additional 7 screws from the front of the PCB at these locations. Do note, for this particular Waterblock installation, you need to make sure you keep this screw from this position handy for a later step. Once those screws are removed, tip the card up and remove the 4 very tiny screws from the I/O bracket at these locations. Save these 4 screws for later steps as well. Once the 4 I/O bracket screws have been removed, it's time to pry the card from the backplate. I like to apply a bit of pressure at the 4 corners of the card between it and the backplate metal. This will loosen the bonding from the backside thermal pads. Now we're getting this thing down to a more acceptable size. Next up is to remove all the factory thermal pads from the front and the back of the card. I use the flat side of an orange wood nail stick to very lightly scrape the pad material from the components. This is a somewhat tedious task, but thankfully not difficult. On to removing the factory thermal paste from the die. 91% alcohol, Q-tips, and patience are the order of the day here. We're looking for a clean, almost mirror finish, if not an actual mirror finish. I don't usually go overboard trying to clean the SMDs around the die, but I will use a high-quality watercolor paintbrush and 91% isopropyl alcohol to at least put a modicum of effort toward cleaning them. However, they can be safely ignored if you like, since the factory TIM isn't conductive. With the die cleaned up, I'll now move on to using Q-tips and alcohol on each of the VRMs, MOSFETs, and memory that had factory thermal pads on them. Once all the components have been wiped down, I'll very lightly go over the whole card with a can of air to dry up any lingering alcohol and remove any thermal pad remnants. One quick note here, the bare card without the fan assembly measures roughly 8 5/8 inches long by 5 inches tall. Now it's time to unbox the Waterblock. This is the EK Quantum Vector2 Master RTX 4090 RGB block in Nickel Plexi. First, gotta get the thing unwrapped, and then flip it over so the back is facing up. There are 6 screws that need to be loosened at these locations. Do note that these are captive screws that connect to small standoffs on the underside of the backplate. This simply means that you should not remove these screws, but rather loosen them just enough so the backplate is able to be lifted up and off the waterblock. If a screw is fully removed from the standoff, they are very easy to lose on account of their tiny size. However, EK does send a couple of replacements in the bag of installation hardware. Next is to start cutting the new thermal pads and placing them on the appropriate areas of the GPU circuitry. There are 2 sizes of thermal pads, and it's important to cut and place the right pads at the right locations. I'll also be sure to remove the protective film on both sides of each thermal pad before they are applied. For now, I'm only concerned about the thermal pads for the components on the front of the PCB. Once all are in place, I'll use the included Thermo Grizzly thermal paste by squeezing a small amount on the die, and then use a plastic spreading knife to create a thin and consistent layer of TIM on the die surface. Now I'll take the 5 screws I removed and set aside earlier in the process and reattach the I/O bracket. First, I'll lightly thread the screw on the front of the PCB, and then tip the card up and put the 4 small screws back in, tightening each down, and finally returning to the screw on the PCB face and tightening it all the way down. Before I attach the card to the water block, I'll reposition my setup so that the end of the water block is barely overhanging the edge of the work surface. Then, I'll gently sit the PCB face down on the water block, being careful to align the screw holes with their respective positions. Once in place, I'll start to add the 4 M2.5 by 4mm screws around the die area, being mindful to put the included PVC washers between the screw head and the PCB. These screws do not need to be hulked into place. I'm being careful to avoid over-tightening. Tighten each screw gently in a cross-corner pattern. After all 4 screws have been tightened down around the die, insert another 2.5 by 4mm screw in this location with a PVC washer. Lastly, use an M2.5 by 6mm screw without a washer in this location. On to the backplate. There's a number of places on the backplate that need thermal pads placed prior to installation as well. I'll check and double check that I'm putting the correct thickness of thermal pad in the right place according to the waterblock installation process from EK. I'll also be sure to remove the protective film on both sides of each thermal pad. Once all the thermal pads are installed on the backplate, I'll position it over the PCB, align the holes, and gently sit it down into place. The last step is to gently screw down the 6 screws on the backplate to secure everything together, and thus complete the 4090 waterblock installation. One thing to mention is that EK does make a 0.6 Newton torque driver that can be used to tighten the screws for a GPU install. While I do own and use several of these torque drivers, I don't prefer to use them on the GPU install, but that's a personal preference more than anything. So that's the regular installation of the EK Master Waterblock for Gigabyte 4090 cards. I wanted to show the process in its native glory, but there's a modification I'm going to make so that I can use this 180-degree angle adapter for the 4090 power plug. Unfortunately, there's about 3/16 of an inch of aluminum on the backplate that I'll need to take off to accommodate the size and shape of this adapter. I'll disassemble the backplate, add paper and masking tape to protect the newly placed thermal pads, and then use the Dremel out in the shop to remove the small area of aluminum from the backplate. After slapping the backplate around with the cutoff wheel, it now looks like this. I'll remove the paper and tape, reassemble the backplate to the card, and test that everything fits well together. The angle adapter now fits perfectly into place, while also hiding the exposed section of aluminum, eliminating the need for me to paint it black to match the rest of the backplate. Boom, headshot. Now the installation is complete. With the motherboard and GPU all fixered up, it's time to get them onto the frame. I'll hold the motherboard in position and lightly thread all 9 screws. With all the screws started, I'll apply a small amount of upward pressure on the very bottom of the motherboard to ensure it's seated as far up as it can go, and then from the bottom up, tighten each screw completely. This really isn't an ideal way of installing the motherboard, but like Macaulay Culkin, I'm home alone and haven't yet installed the carry handles to the frame, so this is just going to have to be how it is right now. Lastly, I'll remove the second and third bezel shields on the backplate, put the GPU in place, and secure it to the backplate with 2 screws. That's going to do it for this video. It's worth saying, but I may never make another video again. But if I did, I'd probably install the carry handles onto the frame and put the hardline water cooling system in place. I hope you've enjoyed this demonstration. Thanks for watching, and out.